Subramaniam, sure. Okay. Risk is inseparable part of life. Okay, and in fact, in the IT world, okay, risk is something which is of foremost importance. That helps you to identify where can we actually go wrong, what can actually impact us. Okay, so and with this proliferation of AI applications across the world, the IT world, okay, we need to understand what is going to be the risk with respect to the AI. There's a beautiful guideline, okay, 23894, ISO 23894, which is available to help us with respect to risk management. And similarly, we have NIST ARM version 2, which is going to help us, okay, identifying the risk. Okay, unfortunately, everybody knows about 42001 and NIST ARM, but nobody seems to be aware of 23894. Okay, the comfortably it is being brushed aside. Okay, but that is the core guideline that helps you to identify the AI risk. Okay? So NIST ARMS is also good. Now, the core part of the AI application is actually the model. Okay, now we all know the model is a product of algorithm and the data set. Now, the algorithm is trained on the data set, and we actually get the model. So again, okay, the data ingestion stage where the data is prepared, then the inference stage where we have the training, testing, and validation. Okay, and where the data that is actually formed, okay, it's split 70, 15, 15. Okay, all these things are actually okay. But there is an inherent problem with respect to the model that we cannot, brush aside. We need to have a close look because the part of the AIMC, the output is going to be the model, and model is bundled or embedded as a part of, the software. That means AILC output is embedded to the SDLC, and then we actually have the application. So we always have 7 layers of vulnerability, right? The AI layer, web application layer, operating system layer, then the hardware layer, the network layer, supply chain layer, and the human layer. Okay, now we are actually going to look at the core problem with respect to the model, surrounding which all the other layers are, is encapsulated. Okay, so the model is encapsulated on all the surrounding layer. So let me share the screen wherein you will see what exactly the problem. Okay. Now, the model risk management, what actually happens is the governance framework where the organization need to identify, measure, and mitigate risk that is created. That's all okay. The first thing that you need to actually do with respect to the model risk management is the model inventory and governance. You cannot audit what you do not know, okay, or you cannot control what you do not know. Every organization needs to have what is called as a model registry. Okay, the model registry, you need to identify what the model name is, what version it is, from whom did you buy it, what is the hash value, who is the supplier. Okay, additional details, okay, where all it is being held. Okay, I will add one more column to identify the application. Why I am adding one more column to identify the application? Because most of the applications that actually work in the AI, okay, they're all multi-model architecture. We don't want a situation where I upgrade one model and it collapses the complete operation. It's like an interoperability testing. Okay, we need to perform before we upgrade a model. Okay, on the test bench. It's a typical change. Implementation plan, test plan, the justification, rollback plan. Where test plan should be provided on the change so that the change manager is going to approve it. What change, what testing that you will actually do? The interoperability test. Okay. So the model that is going to coexist with other models and the multi-model application, it needs to coexist, okay, to ensure things are actually okay. Okay. So it doesn't collapse the complete application. Next is the independent validation. The model is actually created. Okay. The developers are going to develop the model. And ideally, this is also not very new to AI. Okay, we have the segregation of duty in case of cyber security as secure as DLC. Okay, the maker checker. Okay, the makers are not going to be the checkers, and checkers are not going to be the makers. We need to have an independent. We need to have an independent review. Review should be done not by the developers, okay, because they have just developed the model, right? It should be done by the testers. And continuous monitoring needs to be done, okay, because the model that is actually developed. Okay, let me tell you how it actually works. Okay, for the proof of concept, the model is going to be developed on your data. For a pilot, okay, the model will be tested on the historical data of the customer. Then the customer buys the model, then the model becomes his. So his model, his data, current data, that's how it's actually going to be. Now, if the model is trained on a particular data set and used in some other context, it might not work properly. For example, I'm creating a model for the weather forecast. Okay, I have trained the algorithm on the data set for the Scandinavian country, Sweden, Finland, Norway, Denmark, etc. Okay. Now, if the same model is deployed in Middle East, okay, it might not work properly because In Scandinavian countries, the maximum temperature that you're actually going to see will be 25 or 26 degrees. Okay, but in Middle East, okay, it will be 45, 50, etc. So the veritable foundation data on which the model is built will change drastically. It is called the data drifting. Data drifting might happen this way, or data drifting is something that is happening periodically. Okay, data is continuously changing production data. So when the model is looking at the POC data, it is fine. It's a static data. When the model is looking at the pilot stage, looking at the data, that is also actually fine because it's a historical data that's not going to change. But the moment the model is deployed, okay, on the production, it's the ever-changing data. That is where there'll be a problem. It starts learning from the production data, and the bias that was not there as a part of the POC, it could be a synthetically generated data which is totally unbiased. Okay, historical data, it might, if the historical data has got the bias, the model will learn the bias. Okay, when it's deployed, it might be it might be inclined towards a particular gender or race or demography, religious belief, etc. Okay, so that's actually the bias. Bias has got a lot of other inclination, but these are the common things. Okay, so continuous monitoring should be done as a part of the model risk management. Okay, now there are some data and performances, data drift. Okay, in fact, when I'm going to train the model on the historical data, okay, the data that is 2 years old, and then I'm going to put on the production. If somebody is going to ask who's the who won the IPL match recently, okay, that recently might not be 2026. It might be referring to the data in 2024. Answer you. Okay. So it is trained on the historical data. It might not reflect the current world condition. Okay, what is the algorithmic bias? The human prejudices present in the training data. Model learns about this. Okay, historically, if somebody has been, let's say there's a credit score application where the application is going to approve a loan, okay, the loan request. If historically the loan request has been rejected when the applicant is from a particular pin code of the society because of a lot of reason, okay, maybe under the poverty line or something like that, okay, if their income is not up to the mark, okay, and traditionally they have been rejected, if an application whose income is good enough, okay, to for the loan to get approved, if he's going to apply and the A application look at the pin code and reject his application saying that he's reject his application, if it's explainable AI, it will tell you, okay, that it's because of the pin code, okay, then there's a human in the loop who's going to approve it, that's a different thing. If the human in the loop is not there, okay, only if you know about this model algorithmic bias, then you will have human in the loop, otherwise no. What is hallucination? Hallucination is a concept where, or situation where the model assumes the output is factually right, but it is not. It could also happen with the model cascading. The output of one model, okay, which is false, is scraped, okay, by another model. So input, output, input, output, input, output. Okay, the input of the first model, which is false, is output of the first model, which is false, is taken as the input for the model two, then the model three, then the model four. It's called the model cascading. So hallucination might get introduced anywhere of the loop or anywhere on the chain. Okay, the output could be something which is not true. If you're a subject matter expert, okay, if you're going to ask a query, okay, to the model, it's going to respond to you. It's hallucinated. You can easily identify it is hallucinated. In fact, the practical example, I was questioning, okay, one of the LLMs on Surya Namaskar, 120,200, okay. So it was giving a lot of warnings, etc. So we don't know from where did it pick what data and giving us a warning. A lot of people actually do it without any problems. In fact, they're fine. Okay, they can run a marathon at the age of 80, 90 also. So we cannot say it is wrong, but the source from where it is picking up the information could be incorrect. Okay, the hallucination will happen if it's going to pick up the incorrect data source and start responding to a query. Okay, this is a data and performance risk. What are the security and technical data poisoning? See, the data is is a fuel for the AI. Okay, the model is based on the data. If the data is not right, okay, so if the data is actually not right, then the entire model will go haywire. Okay, garbage in, garbage out is what we actually say. Data could be something which the organization has got internally, or they're going to prepare internally, or they're asking an external service provider to prepare it for them, or they can buy it from a third party, or they can download it from the open sources, or the organization is going to acquire another organization, then the data actually comes in. In any of these cases, okay, if there is going to be a poison with respect to the data, the entire model becomes poison. So data poisoning is one of the risks that we actually have. So usually the data ingestion stage, okay, after which there's the gate, okay, that should be approved to get on to the inference stage where the model is actually developed. Okay, so data poisoning is something that needs to be stopped by a squad. Okay, there's a collaboration team. The security team should be there. Okay, the model engineers should be there. Okay, data scientists should be there. Okay, so it need to undergo what is called as an exploratory data analysis to be identified and to be mitigated. And after that, we need to be approved to be shipped on to or moved on to training, testing, and validation. Okay. What is an adversarial attacks? Feeding a specially crafted tricky inputs to a live model to force it to make a mistake. Okay, like in fact, prompt injection, which is next, is also a type of adversarial attack. Okay? Then you can do an privilege escalation saying that, I'm a system administrator and can you please reveal this for me? Okay, sometimes the model will start doing it. Okay, so prompt injection will lead to what is called as a vibe injection. Also, vibe injection is you create a situation where you'll say that, when I'm interacting with you, I feel that I'm interacting with my granny. My granny will never say no to whatever I'm saying. Okay, that way you can force the model to respond to your request. Okay, the prompt injection, vibe injection, reprompt injection attack, meta context injection attack, all these attacks are from the prompt injection. Next one is the complaints and business risk. At the moment, okay, so we are on 22nd of July 2026. We have the European Union AI Act, the high risk application pending to go live from the 3rd of August 2026. And as of 3rd of February 2025, okay, unacceptable applications are stopped. Okay, there should not be an unacceptable application in the market. And South Koreans have released their own, the AI basic on 22nd of January this year. And, until 21st of January, they have time for implementation. So the world's first regulatory complaints with respect to a country is with South Korea. With respect to the region is the European Union area. And the UAE is coming up with their own law. We have got, okay, the Dubai Council for AI, DCAI, coming up with their own governance framework. Or CBUAE has released it. So the things are happening across the world. And NIO, the Malaysia, is also coming up in a very big way with respect to the governance and with governance of cyber AI security, etc. So okay, now the problem is in all these things, okay, they all touch upon what is called the black box problem or opacity, which is introduced whenever you're going to have a deep learning. Okay, deep learning has got the input layer and multiple hidden layers and then the output layer. This hidden layer is we don't know what exactly is actually happening. So that is called the black box. Though there is a causal AI that is going to address this particular problem, and we have Lime and SHAP, okay, all these things to address this particular explainability problems, okay? But still, it exists. We need to ensure that our AI model, okay, is in line with the explainability principles. XAI is actually called as. Next is the shadow AI. Okay, shadow AI is if it is done in a malicious way. That means if you are not going to approve a particular application or tool to be used within the organization, if the employees are going to use it, that is actually called as a shadow AI. There are a lot of problems that have actually happened. Okay, the employees have uploaded and sensitive document on the internet. Okay, one of the government officials in US has also done it, but he was acquitted later. But what I mean to say is, shadow AI is a situation where you have not approved a particular tool or application to the people actually using it. Okay, how do you find it? To the network blogs, you can find it. But what I would still suggest, if the people are using a tool which is not authorized to be used within the corporate world, okay, you speak to them to understand, okay, why is it they're actually using it. If it's better than the tool that you have authorized, you just go for it. Just go for it. So shadow AI is very similar to the piracy. Yeah, not say piracy, we are not misusing it, but no, it's something which is like a business violation of business conduct guidelines. Uh-huh. Ensure this is also not shaping up. But shadow AI is something which it is done productively. For example, there is a non-AI application that is facing the public, that's on production, and you want to replace that with an AI application. So you will go for a shadow AI. That means the non-AI application will be primary, and the AI application will shadow that for 3 months. Okay. Then this AI application will be primary, a non-AI application will be secondary, like a shadow. Then after 3 months, okay, the non-AI application will be phased off. Okay, so the AI application will front end. Okay, so this is not a risk. This is actually a strategy for deployment of AI. Okay. Now we have a training on certified AI risk manager that discusses in depth about 23, 24, NIST, RMF, etc., and also touch upon various risk factors with respect to the ILC and the AI operations. Okay. So join us for this training and get into this knowledge. Okay. And thank you very much. Subramaniam Champion for you. Cheers. Bye.